So it turns out that with our logarithms, you can actually do some pretty impressive things. There are a few different properties of logs that allow you to combine them in ways that I hope will make sense, but also allow you to make complicated problems much more simple. So let's get right into them. First off, we're going to just do a very brief review of some exponent guidelines, because remember, logarithms give us exponents. There are going to be some parallels between how exponents work and these log properties that we look at. So take a look here at the top. If you've got x to a power times x to another power, the question is, when you combine them, what do you do with those powers? So an example here off to the side. If we do something like x to the third times x to the seventh, you're going to end up with x to a power. What's that power? Don't overthink it. X to the third means you have x 3 times multiplied together. X to the seventh means you have x to multiplied by itself 7 times. If you then multiply all that, you've got x multiplied by itself a total of 10 times. So you simply take your exponents and add them together. That's not new. You've been doing that for years. When you're looking at a division, well, let's do a little bit of similar reasoning. Another little example over here off to the side. If we have something like, say, x to the seventh divided by x to the third, what that really means is we've got 7 x's on the top, all multiplied together. And on the bottom, we've got 3 x's all multiplied together. And if we start reducing, one of those with one of those, one of those with one of those, one of those with one of those, we end up having 4 of them left. So the question then becomes, well, hey, what's a quick and easy way to take the 7 and the 3 and get a 4? I hope I can convince you that it's just a subtraction this time. Top exponent minus bottom exponent. So we can see that when you multiply expressions of the same base, exponents are added. When you divide expressions with the same base, exponents are subtracted. Now, let's branch into the wonderful world of logarithms. There are so many logs here, we could build a cabin. Logs, like a log cabin. All right, here's what I want you to do. Do some pausing and unpausing, because I want you to be able to check as you go. In each of these on the left equal a single log on the right. Your task is to find out what number this is. So for example, let's take a look at the first one. Log of 5 plus log of 6. I'm going to pull up my calculator. Let's just see how much that is. Log of 5 plus log of 6. All right, it's about 1.477. So that means that when I'm looking now for a single log that gives me that same result, you can do a little guess and check, but let's narrow it down. So the exponent, remember when there's no base written, it's a base 10. So I'm saying the exponent I put on 10 is going to be about 1.5. So that's going to be somewhere between 10 to the first and 10 to the second. So somewhere between 10 and 100. I know that doesn't really narrow it down much. Let's just try 50. Okay, that's too big. 25. That's too small. Let's go a little bigger. 35. That's too big. And eventually we can narrow it down until we find one that matches. So coming back here to this page, the x that makes this true is 30. Log 5 plus log 6 is the same as the log of the single number 30. So do a quick pause here. I want you to make some educated guesses as to what these others should be, and then unpause when you're ready to check them. Now, I hope that you did that pausing, because I'm just going to give you answers here, see if we can find the pattern. On this one, the x needs to be 10. On this one, the x needs to be 25. On this one, the x needs to be 1,000. And on this one, the x needs to be 99. I hope it does not come as a shock to you that the way we're getting these numbers is you take the first number in the log, the second number in the log, and you just multiply them together. That's all that it is. So property 1, if you've got a log, and there's nothing special about base 10, it can be any base, plus another log of the same base, you can combine those into a single log. where you take the inside parts and you just multiply them together. That's property number 1. Now, I do want it to make a little bit of sense. Think about what's happening here. Logarithms give us exponents. When exponents are added, what that means is you're taking those original base expressions and multiplying them together. Let's see if you can figure out why that makes some sense. I bet you can. You're smart people. All right, let's continue on. A similar thing now with this next group. Let's again take a look at the first one together. So log of 20 minus log of 5. Log of 20, I don't need parentheses, minus log of 5. All right. Ooh, 0.6. So 0.6 is between 0 and 1. That means that the exponent I'm putting on 10 is between 0 and 1. So 10 to the 0 is the number 1. 10 to the first is the number 10. So I need to pick numbers between 1 and 10. Let's just try 5, see how that works. Okay, that's too big. 2, that's too small. Do a little guess and check. You'll eventually end up with, all right, these separate logs are equivalent to this single log. So in this particular case, the x needs to be 4. Do a quick pause. I want you to see if you can come up while I turn the lights back on. Son of a gun. Backlights. Well, better now. Let's see if you can come up with all these others. So quick pause. Okay, on this one, you end up with x being 10. On this one, as a fraction, it's 5 over 2. If you came up with a decimal, it would be 2.5. Here, once again, it is going to come up as a fraction with 17.9, which as a decimal is that 1.8 repeating? Yep. So 1.8 repeating. Over here, let's see, does that come out nicely? Nope. Okay. So once again, it would be a fraction, 375 over 17, which as a decimal is just 22.05, on and on. It just goes on for a while. So the property, the exciting shortcut that we're going to be able to take advantage of. When you've got two logs that are subtracted, yes, you can put it together in a single log. And the way you do that is with division. The one in the front divided by the one after the minus. That is our property number 2. Logs of the same base that are subtracted can be combined into a single log where you take the number in the front divided by the number in the back. Now, by the way, it works both ways. So if you start with a log that's got a division in it, you can split it into 2 separate logs that have a minus in between them. If you've got a log that has 2 things multiplied together inside, you can split it into 2 separate logs and put a plus between them. We'll take advantage of that a little later on. So that comes from here, the idea that division leads to subtraction of exponents. There's one more we're going to look at, and that's this one down here. And it may be a little trickier to see what's going on this time, but I still have faith in you to get things figured out. All right, so this first one, 3 log 2 equals log x. Let's come back here. Let's see how much 3 log 2 is. All right, so 0.9, so it's not quite 1, meaning that the number I'm looking for in this log is probably going to be a little bit less than 10 to the first, which is 10. So pick numbers that are a little less than 10. Let's see, 8. Oh my gosh, 8 works out perfectly on the first guess, like a boss. So the x this time is the number 8. I'd like you to do some experimentation. So do a quick pause, unpause when you're ready to check. The second case, you should end up with a 36. Here you would end up with a 4. This one should be a 32. And this one is actually going to end up being a fraction, 1/9, or the decimal is 0.1 repeating. Were you able to figure out the pattern this time? If you weren't, I want you to try. So do one more quick pause. See if you can figure out the relationship between what we started with and what we ended with each time. What you're seeing is that this coefficient in front acts like an exponent when it moves inside. 6 to the power of 2 is what gives us 36. 16 to the power of 1/2 is what gives us 4. Remember, a 1/2 exponent means a square root. Square root of 16 is 4. 3 to the negative second is what gives us this 1/9. 3 to the second is 9. The negative exponent flips it upside down. So the third and final property is what I call the down in front property, because it says that if you've got an exponent inside of a logarithm, and just to be consistent, I'll put some parentheses in here again. An exponent inside a logarithm can move down in front as a coefficient and give you an equivalent expression. So next up, we're going to be using these three properties to do some very fancy things with our logarithms. Get pumped, yo!